Now let's just see the next question, that is question number 5, which says that in the figure DRC is equal to the area of DCP and the area of BDP is equal to the area of ARC. Then show that both the quadrilaterals are trapeziums. They are trapezium. So if it is, if we just wanted to prove that they are trapezium, so in order to prove that they are trapezium, it is enough for us to prove that one side is parallel to the other side. So let's just start proving this thing. First of all, let us suppose if I'm starting with DCRP. So as you can see in DCRP, we know that the area of this triangle is equal to the area of this triangle. So let us suppose if I'm just starting the solution of this one. So as per the given condition, we know that the area of DRC is equal to the area of DPC. It is given to us. It implies that since we have the two triangles over here, and the areas are equal to each other and they are lying on the same base DC, it implies that they are lying on the same parallels. They are lying on the same parallels. So it implies that if the two triangles are on the same base and equal areas, then they lie in between the same parallels. So using this particular theorem, we can say that DC is parallel to RP. We can say that DC is nothing but parallel to RP, which implies that one pair of opposite side of the quadrilateral, which is DCPR is parallel. It implies DCPR is a trapezium. It is a trapezium. So let us suppose we are done with the very first part and I'm moving on further toward the second part. So for the second part, in which we have to prove that ABCD is also a trapezium, so again I'm just starting with the given condition. So first of all, it is given to us that the area of BDP is equal to the area of ARC. It is given to us, and furthermore, from the previous thing we also know that, let us suppose if I'm calling it as 1 and 2. So from 1 we know that area of DRC is equal to the area of DPC. We can say this thing from 1. So let us suppose if we are just subtracting the 2, subtract 1 and 2. So we are just subtracting the first and the second equation as the area of BDP minus of. So actually I'm not subtracting BDP with DRC. I'm just subtracting BDP with DPC. Why so? Because we know that BDP and DCP or DPC, they are lying on the same side over here. So that's why I am just taking this equation as nothing but area of DPC, which is equal to the area of DRC. So I'm using these two and I'm subtracting these two as area of BDP minus area of DPC, which is nothing but is equal to the area of ARC minus the area of DRC. So when you will subtract the area of these two, you are getting the answer as nothing but area of BDC is actually coming equal to the area of ADC. So when we will subtract these two areas, out of these whole triangle, then we will get only this portion and this portion. It implies that we are getting the areas of the two triangle being equal to each other, that are actually lying on the same base, And so now we can say that since triangle BDC, triangle ADC are on the same base, and have equal areas, then they lie in between the same parallels. the same parallels. This is nothing but the converse of the theorem, which implies that AB is nothing but parallel to DC. And if AB is nothing but parallel to DC, then what can we say from this? That one pair of opposite side of quadrilateral ABCD is parallel. It implies ABCD is a trapezium. This is nothing but a trapezium. So hence we are done with the proving of both of the cases in which we have proved that the quadrilateral DCPR is also a trapezium, and in the second case we have also proved that ABCD is nothing but a trapezium. And with this question, this is nothing but the end of the chapter, which is called as the area of the parallelograms and the triangle. So I hope all the concepts that we have done, for instance, we have talked about the planar region, we have talked about the congruent figures related with their areas, we have talked about the parallelograms on the same base between the same parallels, triangles on the same base and same parallel, triangle and parallelogram on the same base and same parallel. I hope all the theorems and the concepts and the questions that are related with all the theorems are all clear to you. Now do practice more and more questions all by yourself.